California. Take it away.
I actually don't work for Steve anymore.
Oh,
I now work for Mark.
Sorry.
So,
Mark.
yeah, Steve couldn't make it today, and he said, "Would you mind coming back and giving this presentation?" So, I'm filling in for Steve. So, I was working within Steve's group in the plant sciences department. I was managing an oilseed project that was looking at a number of different species, but primarily focused on canola and camelina. And I know over multiple decades, there's been a lot of interest in these species in California. And actually, I got a few emails from people who were attending today saying, have you got notes on it? So I know there's this background level of interest. Just to be clear, the project finished in at the end of 2015. So at the moment, there's nobody formally doing oilseed research on these species in the state. But even though I'm actually not on the project anymore, we don't actually have a funding stream. We do have some a production guide in the works. And a few bits of research that are coming out at the moment are going to be published in the next couple of months. And so if there are questions and that sort of thing, you can give us an email or call us and we can hopefully answer them for you. But this was it was a multidisciplinary project. We had a lot of people from across the UC system. And I did want to acknowledge the level of effort we had from quite a few people, some people in this room, the various extension centres and people who are involved in it. Canola and camelina. I know some people are familiar with it. I know some people in the room are actually growing them at the moment. Canola is going to be the one that's probably most familiar to people. People do grow it around this area. This is actually from the North Dakota. Canola, if you've ever had broccoli or cabbages growing and they bolt, they look like this. It's very closely related to those. It's in the Brassica family. This is what canola seed looks like. It's in the mustard family, so it's got these little black seeds. Most of the US industry is located up here, and really, in some sense, it's like a Canadian industry. They just tapped into the very large. Canada is the biggest producer of canola in the world, followed by France, Germany, and then Australia. And so they just tapped into the infrastructure and are able to sell across the border. There's a little bit grown elsewhere in the country, but it's trivial, the amount. Camelina is also in the Brassica family. It's a bit more distantly related to broccoli, cauliflower. It looks kind of similar superficially, and these are what the seeds look like. There really isn't much of a global market for camelina. It's native to Central Europe. It was grown, both of these species have been grown for thousands of years. But really, production of camelina declined substantially after the sort of Second World War, and it was sort of basically pushed out by much higher productivity oilseeds, primarily canola. But this is what there's actually canola in the background there, and this is a camelina field. Okay, so what are these species used for? We've all seen canola oil at pretty much every supermarket in the country. It's very common cooking oil. That is the primary use of it. Conrad, something's just come up on your screen here, dude. Oh, can't see it up here. It's also used in food production, in food processing, like corn chips and other processed foods, bread, that sort of thing. Let's see if this works. Yep, that's fine. Camelina oil is suitable for human consumption, but I've never seen it for sale outside of, in preparing for this talk, I went on Google and said camelina oil under shopping, and you can actually buy it online. It's marketed as a health food. It has some interesting sort of fatty acid breakdown. It's more similar to fish oil, which is why people are interested in it, but at the moment there's really no market for it. As well as oil, after you've pressed the seed, the leftover seed cake from canola has a large market in and of itself, and often that's more valuable than the oil. And so it's actually, I mean, within the US, other countries, it's already used for cattle and chickens and sheep and pigs and that sort of thing. So this is from the latest figures we have from the USDA. This is actually the beginning of 2015. There's nothing for the past couple of years. But this is imports of canola products and our domestic production, and it's about 4 billion at the moment. Prices, I mean, you can see it goes up and down, but it's continually growing. So we're actually importing about 3 to 4 times more than we're producing domestically. So there's actually quite a bit of scope to produce more within the US. So the big question, is there a place for it in our systems here in California? The idea is that both species would be a complement to winter cereal production. That's how it's used elsewhere. I'm from southwestern Australia originally, and there 30, 40 years ago, we have a very similar production environment to the Sacramento Valley, but we have hardly any irrigation water. So it's actually much more similar to the systems you might see around Rio Vista, the Montezuma Hills. That's sort of what it looks like. And so growers just produced cereals and pasture, and that was it. And so they were looking for something to diversify these winter systems, and they looked at canola. Now, the sort of production systems we have here and in southern Australia, where there's big canola industry, is very different to the canola industry that had developed in the 60s in Canada and Europe, where it's primarily grown as either a serious winter crop where it's like under snow, or it's a summer crop, you're planting it in the spring. And that's quite different to how the industry here would look. But just sort of getting ahead of myself, we'll talk a bit about that. Canola will grow here. That was the one, if there's one takeaway from this talk, is that the work we did over a number of years showed that you can produce it successfully as a winter crop. So this is in the San Joaquin Valley, near the Westside Research Station, big field of canola. We tested it at all these locations here in red. So this is actually the grey area is all the ag land, and the black bits are the cereal producing areas. And we tested it right across the state over 3 years. You can see this is a canola, this is camelina. Actually, they look superficially similar to each other. We tested about 100 different varieties that came from all over the world. We focused on Australian varieties, but we also had a lot of US, Canadian, European varieties in there too. Here's another one. This is camelina. This is canola. From what we did, like, to answer this question, which is what people are always asking, it's based on what we saw. How do we think we could say? Well, be very wary of US production guides, as I was saying. The canola will be produced in a fundamentally different way here. If you want a production guide, and we have one that is being worked on at the moment, but if you're looking around for production information, try and look at information from Australia, because it's much more similar. The production systems there are much more similar to here than elsewhere in the country. Also, you're planting canola at a very similar time to wheat, maybe just a little bit earlier, and harvesting it at the same time. You can produce it with conventional small grains production equipment. If you've got modern planters, modern combines, things, they usually, if in the guide, like in the manual, they'll have settings for canola. But it isn't wheat, and so it requires some slightly different management. Okay, variety selection. This shows you some different plots of canola, and you can see this one here, it's a much shorter season variety than this one. It's already dried down, these ones haven't. One of the biggest mistakes people make, and I know we're talking to a guy who's growing it at the moment, and he's grown it previously and was telling me about the yields he was getting. And people will bring in varieties from Canada or the Dakotas, and they are long season varieties, and that's a problem. Because a long season variety, you plant it in the fall and it will start maturing as we're going into spring and summer. Canola is very, very sensitive to heat around when it's flowering and setting seed. You get conditions over about 90 degrees and that will kill the developing seeds and it'll depress your yields. So you need shorter season varieties that are going to be maturing just like early spring, late fall, sometime in there, while the conditions are still cool. Now, there's a problem. If you plant a very short season variety, it'll just flower and set seed too quickly. It hasn't put on a lot of leaves. It's not able to support high yields. So you're trying to strike this balance up. This variety here seemed to be striking a good balance. It was late enough that it could support high yields, but you can see these ones, well, I mean, I can see it, where some of them, they're still flowering. It's actually got some pods on it. It's sort of, physiology is a bit messed up, whereas this one's much more uniform. So if you're bringing in varieties, one of the key things to achieving high yields is to make sure you're picking the right ones. We tested, so as I said, about 100 varieties. This is a sample of them. These are the yields. It's in kilograms a hectare, but it's similar to pounds an acre. And you can see some of these varieties here, these are like long season or winter varieties. I should say that winter varieties, it doesn't get cold enough here for them to flower, so don't try winter varieties either. But then you can see some of these varieties, much higher yields. So variety selection is critical to ensuring high yields. Other members of our group did some economic analyses and said, you know, obviously it varies from year to year, but if you want to be economically competitive with cereals, you need to get over about £3,000 an acre, given, you know, the average price that you would receive for canola in the US. So you can see a lot of these varieties, no, they're not going to, maybe some of these ones in a good year, but these varieties up here, these are the ones demonstrating that there are varieties that on average will be achieving economically viable yields. Okay, I haven't mentioned Camelina in this context yet. This is the data from the project on Camelina yields. And so it's the same scale. This is why we tend to focus on canola after all this work, because Camelina just doesn't have the yield potential that canola does. So, and also I didn't put error bars on this. These are pretty stable, these yields. This is just all over the place. Camelina hasn't had decades and decades of variety development and breeding that canola has. So it's an undeveloped crop. It doesn't have a very high yield potential. Even like the very best ones are only just slightly higher than the very worst ones. So this is a reason why you want to think twice when people say, well, this is a fantastic crop, it's called Camelina, you should grow it. That being said, there are reasons people are interested in Camelina. This is Camelina, this is canola growing right next to each other. This is Paso Robles. During the middle of the drought, this site got 4 inches of rain, and the canola grew that big and died. Got nothing off it. This, we got £1,000 an acre off it. That's why people like Camelina. You get 4 inches of rain, you get £1,000 an acre. That may be economically viable when you can grow nothing. You have to make that decision yourself. Now, you might get 20 inches of rain and still get 1,000 pounds an acre. So that's why people are interested in Camelina. So in terms of variety selection for canola though, you want these medium short season spring type canola varieties. There are some of those available commercially within the US, broadly adapted ones. And these are the ones you have to be careful of. These long season spring types and winter types. Don't, if anyone's trying to sell you those, don't. Thank you. In terms of planting it, like I said, you can plant it with conventional small grains gear. If you can plant like alfalfa or something, you can plant this. Because it's a small seed, much smaller than wheat, you need good seed bed prep, better than you would for cereals. So if you've got a lot of trash in it, or it's really clumpy, you need to break that up so you get good seed-soil contact. You plant shallow, it's like 1/4 of an inch. One of the biggest mistakes people make is they plant too deep, and then they go, it didn't come up. And I'm like, it's because you planted it too deep. So you're just tickling it in, and it's very low seeding rates, like 5 pounds an acre. People see the bags of seed, like 50-pound bags, and they cost $500. You're like, oh my God. It's like, yeah, it's because you only planted 5 pounds an acre. In Australia, people will go down to 2 or even 3 pounds an acre. So you drill it in, that way you get good even seed depth. And you can see the canola germinating here. It's nice even spacing, they're all about the same size. If you're getting like uneven depth, then you're going to have some very mature plants, some very small plants, and you don't want that. Do not broadcast it. People always say, oh, I don't have one, I'll just broadcast it, and it looks like this. You've got some like quite big mature plants and tiny little ones, so when you look at the crop when it's mature, it's like this. You've got big gaps for weeds to come up in, so just don't even think about it. In terms of when you're planting it,
excuse me,
yeah.
What's your spacing per row?
In that picture there was about 6 inches. Canola's very good at compensating for planting density. So you can go from like 5 or 6 inches up to 8, 9, even 10, and you won't see a difference. Canola's, it doesn't tiller exactly, but that's sort of, if you can imagine, it sends up, if there's a lot of space around it, it just sends out branches and fills the space in.
So you couldn't go like the southwall 12 inches?
That would you could, but I wouldn't suggest it. Yeah. So in terms of when you plant it, this is some other work we did, looking at yield. These are different parts of the state. You can see there's a different planting times every like 2 weeks. You can see the ideal time in most areas is early November, and there's a number of reasons for that. And you can see obviously there's a different yield potential. These are irrigated and these aren't, but you can see it's usually around early November, maybe late October. That's when you want to get it in. You don't want to plant much earlier than that unless you've got irrigation, because it's such a small seed, you plant it so shallowly. If there's no moisture, it dries out quickly. If there's no moisture in that shallow soil layer. If you plant much later, you get this. This is average soil temperature for different parts of the state, different colour. Canola has a sowing threshold for temperature. That's 10 degrees Celsius, about 50 Fahrenheit. If you plant it at that temperature or much lower, the seed is very slow to germinate, tends to get rots and problems like that. So you really need to plant it before your soil is at around 50. Ideally, you need about a week of soil temperatures above that to get it to germinate and come up. So you can see that's sort of the latest you want to plant it is sort of like mid-November. Obviously that'll vary depending on the year. You're in. See one of these? Steak.
Is that the same for Camelina, that threshold?
No.
Okay.
Camelina can germinate below freezing. Doesn't germinate very well, but if it's below freezing, it can germinate. That's the other advantage for Camelina. You can plant it all winter if you want to. So you can make that decision. Maybe if it's too cold to plant canola, maybe you can plant Camelina instead. But I suggest if you really want to know, you get one of these, stick it in the ground and see what the soil temperature is. The other way of doing it, just as a rule of thumb, is just the maximum daily temperature, the minimum daily temperature. The average temperature is approximately what your surface, very shallow surface soil is where the canola is planted. So if you're just looking at the daily temperature, just take the average daily temp, and that's about what your soil will be. So you go, there you go, that's the sowing threshold. You know, it's kind of in that range. Irrigation. In southern Australia, where there's 2 million acres or plus of canola each year, it's not irrigated. Hardly any of it's irrigated. Some other work we did. This is a cumulative rainfall yield. As you can see, this is just dry farm canola. As the rainfall goes up, yield goes up, and then it flattens out. That's about in there 20 inches to get 3,000 to 4,000 pounds an acre. So if your rainfall is at that, so you can draw the state up, there's rainfall. Something like this. If you're above sort of the delta, you should be able to grow commercially viable canola with no irrigation. You won't be getting the maximum yields you could possibly get, but you should still be economically viable. If you're south of that, you're going to have to irrigate. It's too risky otherwise. To just illustrate that, this is looking at different management techniques and the sort of yield you could expect to get. Looking at this, it's starting at 3,000. So that's about your economically viable yield. This is modelling work we did for Davis. So around here. Yeah. So no irrigation, you're going to be just getting slightly over 3,000 pounds an acre on average. If you pre-irrigate, just to help it get up, that dramatically increases your yields. A bigger pre-irrigation event, so like filling your profile, even higher. And then other management, so you're like splitting your irrigation. You're putting down 10 inches or so of water initially to get it established, then you're putting some down when it's starting to flower. That's when the water demand is very high. That bumps it up even further. If you've got some pretty good soil moisture monitoring equipment and you can measure soil water depletion, then that's when you really get high yields. This is, we believe with better varieties, you can actually push this up above 5,000 pounds an acre. So irrigation, if you do have it, could be beneficial to your systems. Now, the big thing that canola has a reputation for is being difficult to harvest. And that was a deserved reputation previously. This is the key thing. People freak out with harvesting canola, particularly people who are used to cereals. People have been growing canola in Australia for 40 years, 50 years now. There's been a lot of variety development. Historically, back in the late 70s when they tried canola here in California, it shattered, it was terrible. Okay, there's the variety development since then. There are varieties, like say, historically what they do is they windrow it, let it dry down, then come through and harvest it. The new varieties are so that you can just directly combine it. So the canola will look like this. It will have some green stems on it. This is also a thing people who are used to cereals. They go, is this ready? It's like, yeah, it's ready. It's going to have a green stem. The canopy's all nice and dry and even. You can go up, you can pick up a bunch of it, bash it, it falls apart, it's ready to harvest. In that sense, it's not like wheat. You just can't leave it sitting there. If it's dry, and it's, you bash it, it shatters. If you want to get a moisture meter, you can then check it. It's around 8 to 10% moisture. You have to harvest it within a few days. Like, maybe a week at most if it's sort of nice, calm conditions. Leave it longer than that, the pods will start to break apart, it'll fall on the ground. In our trials, this is one of our small plot combines, we directly combined all of ours. We didn't use any, we didn't windrow it. There's also chemicals that people try and sell that kind of, you spray on the crop and it makes the pods stick and stops them shattering. I've never seen any evidence that that's economically justified, the sort of yield gain you get. You harvest it at the right time, you get very, very minimal seed loss. Because you've got this very thick stem material, you don't harvest it right at the ground, because then you get all this material going through your combine. You actually lift your table up and go like right under the canopy and go through it, so you get this stubble in your field. But that way then you minimise the amount of like excess bulk going through the machine. There's Camelina. Similar things apply to Camelina. So we directly combined all of our Camelina, saw very little seed loss. It's a much smaller, lighter stemmed plant, so you can, and it's often dry the whole way down to the ground, so you can just cut the whole plant. I haven't really mentioned this. At the moment, there's not really an industry here. There are people growing it who have found people to buy their seed. No one wants to tell me who they are though, so it's a little bit shady. There are, yeah, I think they're shipping it out of state. So this is a difficult thing. If you wanna grow canola, you have to make sure somebody's around to buy it. There are like local people who'll crush it and use it for biodiesel production and that sort of thing, but that's a lower value market, so you have to make that decision. There are other ways that, rather than just being like a wheat substitute, that canola could fit into the systems here, and this is one that's quite heavily used in Australia. If you've got a mixed livestock crop operation, what people will do is they'll go in and graze it or harvest it to make silage or even hay. It's a very, very good quality feed, a little bit too good in some cases. You have to be careful about introducing hungry animals onto it. You do this early, say just around the time it's starting to bolt, no later than that. If you've got decent soil moisture, it can recover and give you seed yields that are comparable to what it would have been had you not grazed it. So these dual use systems that provides you with this additional stream of income that you may not have ordinarily had. I can certainly, like talking to people say around Rio Vista, this might be something they're interested in. So we actually did a study to confirm this. This is on campus where we had canola and camelina, and we were sort of cutting it at different times. You can see one we cut there. Every 2 weeks throughout the growing season to demonstrate this in our systems. Just very quickly, some other things we looked at. We were looking at, this is a soil moisture sensor that we had under both canola and camelina, this camelina field, and one of our units. And we were sort of looking at crop water use over time. This is days after planting. And this is daily, this is like cumulative water use, and this is sort of daily. And this is, as you get weather systems and things moving in, it jumps around. But you can sort of see from this, most of the water use of canola and camelina is 3 months after you plant it. If you've got good soil moisture, you don't have to irrigate early on, sort of just enough to get it established. And it's really late in the season. So if you're using that figure I showed you before, like really targeted like irrigation management to really boost yields, this research demonstrated sort of, you're applying it around flowering, and that's when you're getting the most value for that irrigation you're putting on. And last thing, we also were testing this thing called AppSim. It's a cropping model, computer model. This is their website, if you're interested in going to their website. But anybody can download and use this model, and we were able to demonstrate that it was able to predict canola yields within California with 90+% accuracy. So particularly for specialists, if you're a grower and you feel particularly computer savvy, you could actually try doing this and sort of model how canola could work within your systems. I don't know how long I've gone for, Conrad.
No, you're good.
Thank you. That's ahead. I just really wanted, just before I finish, these are my my two colleagues who helped me greatly on this work. That's them pretending to be sheep eating canola. They really have to, they put a lot of effort on that project, so I had to thank them. So. Thank you.
If anyone has questions, we can just take a couple minutes.
What about volunteers?
Good question. Canola, you will always expect to lose, even with very, very good management, 20 pounds an acre of seed. No, so, it's not a large amount of seed, but when the sowing rate is 5 pounds an acre, you will get volunteers. It's a crop that does volunteer. In other big canola producing areas of the world, it's just part of the management of your system is to control those volunteers. So typically, in Australia, they're harvesting it going into summer. We don't have really any summer cropping. So you just let the seeds sit on the surface and ants and birds will come and eat most of it. And then you just manage it like any, the seed viability declines very quickly. So at the end of summer, you've only got like 10% of that seed left. So it's not a particularly big problem. And then because that's in a mixed, canola being a broadleaf and with a cereal system, you're going into cereal, so you just use broadleaf herbicides. Here we're kind of lucky because if you've got an irrigated system, you can just irrigate that seed up. So all of our collaborators, where we were putting trials, they would just do that. They just go through, irrigate it up, it'd germinate, and they just let it die during the summer. And that we didn't have any really serious problems with volunteers.
You mentioned the issue with shattering. What in-round days did you experience any wind events immediately prior to harvest that sacrificed big on yield?
No, we didn't. And it's just that, these newer varieties are much more resistant to shattering. And I was out there, actually, we had crops down in the Imperial Valley. We were out there and it was like 30-mile-an-hour winds, and you're watching the canola like going like this. You get a little bit of shattering, but it's no more than a couple of, 1 or 2% of your total yield. If you get a really big windstorm and you've left the canola standing there, the canola's too dry, then it could happen. But that's, you need to make sure you get in and harvest it before you get to that point. But yeah, across all of our sites, we never really saw any problematic shattering. And that's like, you can get down on the ground under the crop and look, and there's the equivalent of 1 or 2 pounds of seed on the ground, which is completely normal. So,
Does it help suppress disease pathogens?
Yeah, so it complements cereal systems. So a lot of research demonstrates that the farming systems here are a bit more complicated than, say, in Australia, where it's just like a cereal canola system. But the long-term yield from your wheat will be higher with canola integrated into the system because it's able to suppress fungal diseases that affect the cereals. Because it's susceptible to a whole different range of things that wheat is. I actually don't know. I don't know about that. Yeah, it wasn't something we were looking at in our program. And I don't actually think of anywhere else in the world where it's integrated into like a summer vegetable system. So that's an interesting research question, actually. But this is how people using it, because you can, it diversifies the sort of chemical weed control options that you can use as well. Because if you've got a serious grassy weed problem, you bring this into your system, like winter grasses, and then you can use grass selective herbicides and control them. It's also actually, once you get a good crop like this, it's extremely competitive against weeds. Really does a good job of suppressing weed growth underneath it.
Does it grow I'm sorry.
That's okay.
Does it grow symbiotically, or I didn't hear anything about fertilizers?
Oh, sorry. Fertilizer regimes, fertilizer management is very similar to wheat. So if you're growing wheat, it's about the same. It's a slightly hungrier crop for nitrogen. So it's about 20 or 30% more nitrogen than you would for the equivalent wheat crop in your area. But other than that, it's actually very similar. If, like particular, I mean, phosphorus and potassium use is slightly lower than cereals.
Sulfur needs more sulfur.
It does, thank you, yeah, it does need more sulfur. So if you're using, ammonium sulfate or something, blend with urea, then that'll like easily meet that. We actually didn't really see any issues with potassium or phosphorus deficiency. Like most of our soils here have completely sufficient levels of those for canola.
Did you do some pre-plant or?
You mean just fertilizers in general?
Yeah.
So,
Pre-plant.
you have to. This is particularly where that computer model comes in. It's similar with cereals. You have to make that decision about what the yield potential is going to be given your irrigation amounts. Obviously, the more N you're putting on, you need fertilizer amounts that are consistent with what you expect your yields are going to be. More fertilizer, your high yields. And so, if you think it's going to be a very bumper crop, you can go in and do it like a top dress event. Particularly, if it was weather conditions like this, you'd obviously definitely want to do that. So similar to very good wheat management for nitrogen as well. Does that answer the question?
Oh, yeah, thank you.
So some of the brassicas are super attractive to aphids. Did you guys, during flowering, did you guys have any problems with aphids?
You do see aphids on them. I didn't have any pictures of that. Around the world, you do see aphids in canola, but I think of all the research I saw, it was never demonstrated that aphid control was economically viable. You might see like a circle of plants that are all dead, but in terms of the whole field, it's nothing. So we never saw problems across yield suppressing levels of aphids across the whole field. That was just nothing we ever observed over 3 years. Now, across the entire state. I don't know, I don't want to say never. I guess, it might be possible we could get a really nasty aphid event, but as far as I'm aware, Australia, Europe, Canada, it's not an issue.
I was thinking more like when it dries down, the aphids moving the crops around.
No, I never really encountered that. I actually don't know enough about that to say whether it would happen or not, but I guess we never saw aphid populations in there big enough that it would be a problem for anything around it. Interesting question though, actually. I think it was...
What's the typical yield in a major production area like Canada?
Yeah. In Canada, the average yield is around about, if they're doing really well, 1,800 to 2,000 pounds an acre. And it would be high for Australia's like 1,500 pounds an acre. Up and down the east coast, they've got a bit of it in Georgia and North Carolina. That's a typical yield as well. So we actually have very, very high, like internationally high yield potentials here. And it's just because we have a good soil and relatively warm winters, so it allows the crop to put on a big leaf canopy that can support very high yields. So even though, if we integrated it, sort of, if you thinking long term, if we were able to, integrate it as part of our cereal systems here, even though in terms of the whole US industry, it wouldn't be a particularly big acreage, the sort of yield contribution we could make would be very high.
On quality mustard, volunteer mustard in the canola,
Yeah,
impact?
mustard, they're typically not going to be, the mustard weeds won't be setting seed at the same time. I know there's a disconnect. I think they'll be setting seed a bit earlier or a bit later. Around the world, that's not really an issue. The mustard weeds are the biggest problem in canola production though. So if you've got really serious mustard weeds in a field, you don't plant canola in it because you don't have a lot of control options. They look very similar, they behave similar, and so you will get a lot of weeds through it. So that's, you want to make sure your mustard weeds are controlled very well if you want to grow this. The other question you get about that is hybridization between the canola and mustard weeds. It does happen, but it's at such a low rate that it's effectively doesn't happen. If you put them in the lab and you cross them together, you can get it to happen, but it's never been observed in the field anywhere.
Is there an organic market?
There is, yeah. I don't know a lot of details about it, but there is an organic market, yeah.
Are there any herbicides or insecticides that are legal in California if you grow them?
Okay, we were talking about this before. There are some, you can use Roundup on it. Kevin,
Yeah.
is this correct? I know you've looked at it more
if you have
recently.
like a Roundup Ready canola, but
Yeah.
like for Camelina, it's effectively illegal to grow in California
Yeah.
because you can't actually spray anything on it.
You can,
Organic.
you can use Post and Treflan,
but they aren't labeled. Post is labeled in every other state besides California.
Yeah.
Here in California.
They are working on getting it labelled for it. But that is an issue with it, is, you know, a lot of the diversity of weed control options you have in other crops just don't exist. So it's important to use, you know, other methods to get your weeds controlled early. But camelina in particular, is just like, there's nothing you can use for it. I mean, if there is definitely interest in growing these crops and putting pressure on the agencies to get some stuff labelled for it, be good. I really appreciate the interest, guys.
There's one last
Yeah.
question here, yeah.
Two questions. Is this what they refer to as a pulse crop,
No,
like in the Midwest and
No.
Canada?
no. This is a brassicaceous. So pulses being, you know, their legumes.
Okay.
Yeah.
And do you get benefits from nematode control, what
Yes.
have you, just like mustard?
Yes. Yeah. So this is actually very good at controlling nematodes. It's this what's the term? You know, like soil fumigation properties of it. I don't actually know what the chemicals are, glucosinolates and things, but they're actually very good at controlling nematodes and other like root pathogens. Cool.
All right,
Thank you.
thanks a lot, Nick, appreciate it.
Mark, do you want to go? Mark, do you want to give your presentation now, Mark? Is that?
It's up to you.
Yeah, because you got other stuff you got to take care of later today, right? So.
You can go, if you're ready to go, go.
All right, I can push through mine pretty quick. We're going to hand out a sign-in sheet that just confirms that you were here for the CCA, PCA stuff. There's also a question about like ethnicity. Don't get offended. It's just so I can give the federal government numbers. So, you know, if you're not a white guy in his 50s, that would help. Just let me know. You know, like you can write on there. No one else is going to know. Whatever. It's not a big deal. But that's just how it is with these days, regulations, all that. So, and then also, if you want to get the newsletter, if you want me to be in touch with you, put your email on there. I assume you guys somehow got the email, but some of you might have gotten an email about this meeting from Gene, from his list. I'm not going to be continuing to send everything out to him. So if you want to get stuff specifically for like ag crops, put your email on there. I'll add you to my list. Okay, cool. Any questions? Good? Yeah, all right.